All right, guys and girls, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. Today, Unit 12, Notes number 6, we're going to be doing some synthetic substitution and factoring with synthetic division. First, we have kind of a review problem. This is not using what we did yesterday, okay? This is just something that we've done in the past, right here. Evaluate P of x equals x cubed minus 4x squared plus 3x minus 5 when x equals 4. How would I solve this problem?
Put in 4 for all the x's.
Right, replace all the x's with 4. So let's do that. 4 cubed minus 4 times 4 squared plus 3 times 4 minus 5. Right. We're solving for when x is 4. We just plug in 4 for all the x's, and then we just have to solve it out. Simplify. So, what is 4 cubed? 64, that's right. Now the next part, be careful because some people will mess up the order of operations. What comes first, the exponent or the multiplying? Ooh. Yeah, the exponent, okay. Yeah. What? So we're gonna put minus 4 times 16. That's right. Minus 4. Right, but I'm just gonna step by step like this. Okay, then we have plus 3 times 4. 12 minus 5, and then as Trey said, yes, the second term is going to simplify to minus 64. So 64 minus 64 plus 12 minus 5. What's the answer there? Yeah, it's 7. There it is. Boom. So the answer is 7. When x is 4, the answer is 7. But now look at that. So, you had to do a little bit of calculations there. The numbers could get a little big. So there's another technique we can use to find out the exact same thing. And that is called synthetic substitution. All right. So synthetic substitution, there's a thing called the remainder theorem. And when a polynomial, p of x, is divided by x minus a, then the remainder is the result of the function when you plug in a. So we're going to do the exact same problem using this new technique, synthetic substitution. So if I take the polynomial, our original polynomial was x cubed minus 4x squared plus 3x minus 5, and I divide that by, now look over here. Originally we had x equals 4, right? I want that in the form of x minus a, so what I'm going to do is set this equal to 0. So I subtract 4 from both sides and I get x minus 4 equals 0, right? So I'm dividing by what? X minus 4. All right. Okay, so let's do the synthetic division here. We got the polynomial divided by our binomial. What is the a value here? 4. That's right. A equals 4 because all we do is take the negative 4, switch the sign, right? And that's our a value. So this is a. Now what are my coefficients now when I line it up for synthetic division? 1. Negative 4. 3. And negative 5, that is correct. All right, so now we draw the bar. And let's go through the steps. What is the very first step? Bring down the 1. And then? Times 4, which is? Now what do we do with those two numbers? Add them, so that is 0. Now, 0 times 4, which is 0. Add these two together, what do we get? 3. Now 3 times 4, which is? 12, and 12 plus negative 5 is 7. So our remainder is 7. And so this remainder is the result of P of 4. When I plug in 4, because that was my a value, right? When I plug in 4 to this polynomial, the remainder was 7. That means my polynomial is going to equal 7 when I plug in 4. So this is the exact same problem we just did, and look, we got the same answer both times, right? Using the remainder theorem and some synthetic substitution, we got the same answer, 7. P of 4 is 7 both times. First version, we just did normal substitution, we plugged in 4. The second version, we used synthetic substitution. Pretty much. We're just using it for different reasons now. We're using it for different applications. All right, so example 1. Let's try a couple more examples. Example 1, evaluate using synthetic substitution. There's our polynomial right there. when x equals 3. So the original way we would do this is just plug in 3 for all the x's, right? But we're going to use synthetic substitution. So what is my a value? A is just going to be 3, actually. Yes, because to get x minus a, I would have to subtract 3, right? And it would be x minus 3. And looking at that, what's the a? It would just be. So when you're doing this technique, really the x that they give you, that is your a. Okay, that's an easy way to think about it. Right. But you know, you don't really need to move it if you get the if you understand. All right, so what are the coefficients now that I should line up? 1, -4, 5. Nice. There it is. Draw the bar. First step is to drop the 1, then, which is 3 now. -1, then, which is -3. 2 times 3 is 6, and then 7. Oh, what the? 7. So what's my remainder? Which means that when I plug 3 into this polynomial, so p of 3, what's the answer? 7, exactly. That's a coincidence. So p of 3 equals 7. So there we go. And we're going to do one more example right here. All right, evaluate using synthetic substitution. Once again, there's the polynomial when x equals -5. So what is my a value if I use doing synthetic division? Right, a is -5. Okay, what's wrong with my polynomial there? It's out of not standard form is what he said, right? It's not, okay, yeah, it's not standard form. So I need to put in standard form. What would standard form be? That's what I'm thinking. And then? Right? What's after this? -3x squared. And lastly? +5. There we go. Okay, so now it's in standard form. So let's write our coefficients down. What are my coefficients gonna be? -1, -6, -3. What did you say? 5. Wait a second. What am I missing here? The x, right? This should be 0. I don't see an x term, so it's going to be 0. And then 5. There we go. There we go. Boom. All right, so let's get the numbers down. What's the first number? -1. Then, which is 5. Add them, that's -1. Multiply by -5, which is 5 again. 2. -10, because I multiply by -5. -10. 50. -10 times -5 is 50. And then add those, and what I get, that's the remainder, which means that p of -5 is 55. Very good. Right, so this is kind of a nice way to evaluate what your polynomial is going to be when you substitute a number and without actually doing substitution. Because look at this. This is a little harder one, because if I try to plug in -5 for all these x's, watch this, equals -5 to the 4th minus 6 times -5 to the 3rd minus 3 times -5 squared plus 5. Okay, no calculator. What is -5 to the 4th? Do you know? Exactly. So it's kind of hard. It takes some time, right? But instead of doing that, you could just use synthetic division, where the numbers are a lot easier, right? And boom, there's your answer.
Wow.
Yeah.
How'd you get to 0?
How did I get to 0? Because do you see an x term right here? It skipped from x squared to the number, right? The x term's missing, which means that the coefficient on the x term technically is a 0, right? Yeah. So you can see why this technique would be easier in some cases than normal substitution, right? Okay, because, you know, you probably wouldn't know, but like down here, right, the numbers would be very giant. It'd be like, you know, 750s and stuff like that.
Oh, no.
Okay, exactly. All right, let's turn to the back side now. How do we determine if x minus a is a factor of a polynomial? So a factor means that it divides evenly, right? Does anybody know how I would determine if x minus a is a factor of a polynomial? It has to do with the remainder. It has to do with the remainder after you divide. That is correct, Lynn. It is when the remainder is 0. Okay, if the remainder is 0. All right, think about it, right? If I asked you, is 5 a factor of 10? Is it? Yes, it is. What's 10 divided by 5? 2. What's the remainder? 2. The remainder is 2? 0. The remainder is 0, right. If I divide 10 by 5, the answer is 2. There's no remainder. Remainder is the leftovers. If you divide evenly, right, there's no leftovers. Remember? So the same thing right here. If you divide a polynomial by a binomial, if the remainder is 0, then it is a factor. So all you have to do here then to check if a binomial is a factor of the polynomial is do the division, use the synthetic division, and check the remainder. Is it 0 or is it not 0? If it's 0, then it's a factor. If it's not 0, it's not a factor. Okay, so let's take a look at some examples. Yes, it is a factor of the polynomial. Okay, so the first one, we're going to check if x minus 3 is a factor of p of x right there. So we're going to divide and see what the remainder is. So what is my a value here? 3, right. Change the sign. What are my coefficients? 1, 2, and negative 3. Very good. Set it up. Step 1, bring the 1 down. Then we multiply by 3, which gives me 3. Then we add 2 plus 3, which is 5. Multiply 5 by 3 again. 15 plus negative 3. 12. What's the remainder here? 12. The remainder is not 0, so what? Right, remainder is not 0, so not a factor. So x minus 3 is not a factor of p of x. Yeah, it's not a factor of p of x. You don't have to write all of that out, but you do want to write that it's not a factor of p of x. Okay. Probably. All right. This is notes, so we gotta have some variety up in here. All right. So same thing. We're gonna check if x plus 4 is a factor. So we're gonna do synthetic division and see what the remainder is. What is a here? Negative 4. That's right. With this polynomial, what do I need to do with this polynomial? Put it in standard form. How would I do that? Switch the 2x and the 8. Right. Those are the only two that are in the wrong order. So plus 2x plus 8. There we go. So now, what are my coefficients? 2, 8, 0, 2. Why did you put a 0 right here? There's no x squared in between the x cubed and the x. That's right. Very good. All right. So let's put our numbers here. First, we're going to bring down the 2. Multiply by negative 4, which is 8 plus negative 8 is 0 times negative 4. 0 plus 0. 0 times negative 4. 2 plus 0. 2 times negative 4. 8 plus negative 8. The remainder here is... you're right. The remainder is 0, which means what? Of p of x. There you go. Remainder is 0. So x plus 4 is a factor of p of x. Now we're specifying that as a factor of p of x because if you just write it's not a factor, well, it's a factor of something, right? But when we specify of this p of x, then we know what we're talking about. There we go. All right, so that is how you check if a binomial is a factor of a polynomial. Let's go to the last part now. Starting process of factoring completely. Okay, so we've all seen the questions where it says factor completely, right? Where you have to break down a polynomial into all of its separate factors. How can we do this including synthetic division then? So write this down. If you are given a factor, if you are given a factor of a polynomial use synthetic division to reduce the polynomial. Then factor the reduced polynomial. Let's actually go down to example 5 because it'll probably make more sense to do 5 first. Alright, so it says factor the given polynomial completely using the given factor. So we're going to write it out in its factored form, right? Now first thing, when you look at this polynomial right here, you're like, okay, x cubed and there's 4 terms. I'm going to use grouping. But if you try grouping here, you're going to find out that it actually doesn't lead anywhere. Okay? So this is why we have to use the technique that we just wrote. They gave us one of the factors. What's the factor they gave us? X plus 4. So that means in my answer, I already know that x plus 4 is one of my factors. But I need to find the other 2 factors. Right? So what can I do here? I can first use synthetic division to reduce my polynomial. So let's do synthetic division with this factor. So what is a? Right? And what are my coefficients? 1, 2, minus 11, minus 12. There we go. Let's do the division. So we're going to bring down the 1, and then 1 times negative 4 is? 2 plus negative 4? Negative 2 times negative 8. Wow! Negative 2 times negative 4? 8. Negative 11 plus 8? What is it? Negative 3. And then negative 4 times negative 3? 12. And negative 12 plus 12? You know that it should come out as 0. Why? Exactly, because they said that this x plus 4 is a factor. Very good. Good understanding. All right. So now I have these coefficients right here. This tells me a new polynomial, right? What is my new polynomial? X squared. Why did you start x squared? A value down from what? The original. The original started at x cubed, so I'm starting at x squared now. X squared, what's next? Minus 2x? Minus 3, right. So the 1 is the coefficient on the x squared. Negative 2 is the coefficient on the x. And then negative 3 is just the number that is following. There it is. Okay, so now that we've reduced this polynomial by dividing the factor, we have x squared minus 2x minus 3. We should know how to factor this polynomial, right? What method can we use to factor this polynomial? X squared minus 2x minus 3. The X box method, that's right. So using the X box method, what is A? What is B? And what is C? Alright, so let's draw the X box. Boom, boom. What goes in the top? A times C, which is negative 3. Very good. What goes in the bottom? B, which is negative 2. Nice. And then what are the 2 factors in the side then? Negative 3 and 1. Right. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. What do I need to do after I find those numbers? Put A times x on the top, which is 1x, which is just x. So now I found my 2 other factors. They gave me one of the factors, x plus 4. What are my 2 other factors? X minus 3 and x plus 1. That's right. And here is my completely factored form. X plus 4 times x minus 3 times x plus 1. Doesn't matter. The order doesn't matter because it's going to end up being the same regardless. So you can see the method here was to take the factor they gave us, use that to divide the polynomial so we can get a smaller polynomial that we can actually factor out with another method. All right, there we go. So let's do our last example then, which is example 4. Kind of a word problem, so you have to understand what it's asking you, okay? So it says, The polynomial x cubed plus 6x squared plus 11x plus 6 expresses the volume of a box of Reese's Puff cereal. The width of the box is x plus 1 inches. So what are the length and the height of the box in terms of x? Okay, so volume is length times width times height, right? They already gave you the width, which is one of the factors. So how can I find the length and the height? That's probably not going to help in a question like this. So we have three factors, right? The length, the width, and the height. One of the factors is the width, which they gave us. So this is the same thing as the last one. What we can do first here is take the factor they gave us, x plus 1, and use that to reduce our polynomial. So what is our a value looking at this factor? -1, right. What are my coefficients?
1, 6, 11, and 6.
Right. And let's divide. We bring the 1 down. We multiply by -1 to get -1. 6 plus -1 is? 5 times -1 is? -5. 11 plus -5 is? 6. And 6 times -1 is? And lastly, 6 plus -6? 0. You know it should be 0 because they told you that that is the width of the box. It is a factor. So now that I have 1, 5, and 6 as my coefficients, what is my new polynomial? That's right, x squared plus 5x plus 6. The 1 is the coefficient on the x squared. The 5 is the coefficient on the x. And the 6 is the number at the end. All right, so now that I have x squared plus 5x plus 6, I can factor this out using what method? X box. Okay, what is A? What is B? And what is C? 6, that's right. So draw the X box. Boom, what goes in the top? 6, A times C, which is 6. What goes in the bottom? Right, my two factors would be 3 and 2. What goes on top of those? X. Right, 1x, which is x. Okay, so what are the two factors I just found? X plus 3 and x plus 2, that's right. So x plus 3 and x plus 2, and we're going to write inches because remember, we have to use units. Some people are still not writing units, losing a few points there. X plus 3 and x plus 2 inches are the what? What are those? Are the length and height. They already gave you the width, so we're looking for the length and height, and that's going to be these other two factors. You don't really know which is which because they didn't specify, but, you know, those are the two values that are the length and height, and that will end these notes. This was the last notes before the test, guys, so good luck on your studies, and until next time, see ya in the next one. Peace!